Hello, I am Teacher Marichu, and again, welcome to our modular distance learning on MathBox for senior high school on general mathematics for Quarter-1, Week 3C. The objective of this module is for the learners to solve problems involving rational functions and equations. We move on to the generalizations. We have solving rational equations. There are two steps to follow. Number one, eliminate the denominators by multiplying each term of the equation by the least common denominator and solve the resulting equation. Example 1 is done for you. Just go over it. For example 2, it's already done for you. Let me show it here. Just explore the solution of example 2. And let me proceed directly to exercises. We have 4 numbers to solve in the exercises, and let me guide you through the exercises one by one. Let me read out the problem. For number 1, the function below gives the concentration of the saline solution after adding the x milliliters of 0.5% saline solution to 100 milliliters of a 2% saline solution. So the function of x is given as f of x equals 100 times 0.02 or 2% plus x times 0.5% converted in decimal form all over 100 plus x. How many ml of the 0.5% solution must be added to have a combined concentration of 0.9%? For the solution, let x be the number of milliliters of 0.5% saline solution to be added to a 100 ml of the 2% saline solution. And we know, as given in the problem, it says here that f of x is the function of concentration of saline solution. So we have here, what is asked is how many ml of the 0.5% solution to be added to have a combined concentration of 0.9%. So meaning f of x is, we set f of x equals 0.9%. Here, f of x equals 0.9%. This is the goal of this problem. And we are looking for x. How many milliliters is to be added to the present contained 100 ml. Okay, so we have this equation. Equate it to 0.009, the equivalent percent of the 0.9%. Moving on, we have simplifying the left-hand expression, and the LCD here is 100 plus x. So multiply both sides of the equation by 100 times quantity x. 100 plus x. Multiplied it to both sides of the equation. That's why this one here, the 100 plus x will cancel out. On the other side, we have 0.009 times quantity 100 plus x. solving, we have 2 plus 0.005x equals 0.9 plus 0.009x. Then we retain 2 here, then transpose 0.9, it will become negative and equals the 9% x, the 0.9% x minus the 0.5% times x. Then simplifying, we have 2 minus 0.9 is equal to 1.1, and subtracting this we have 0.004x. Then we don't want decimal. I mean, for me, I'm comfortable dealing with whole numbers, so I need to multiply both sides of the equation by 1000, and multiplying by 1000 will give us 1100 on this side. I just swap the sides anyway, it doesn't matter whether, because we just transferred this one, it's a reflexive property of equality. Okay, then the 0.004x will become now 4x because it was multiplied by 1000. And solving for the value of x, before that, we have 4x equals 1100, divide both sides by 4. This becomes 275. So x now is equal to 275 ml. Therefore, 275 ml of the 0.5% saline solution must be added to 100 ml of 2% solution to obtain a 0.9% solution. Now, part of the solution is to check and verify. So I was not able to include it here, but it's for you to check and verify. So you go back. Verifying is to go back to the original equation here and substitute the value of x equals 275 ml. And manipulating on this and coming up with a 0.09 value after substituting the value of x equals 275 in this equation will validate that x is the required number of milliliters to be added to the required solution. So this is the solution for number 1. We move on now to problem number 2. A plumber and his assistant finished a job together in 4 hours. The job would have been taken the plumber 6 hours if he was working alone. How long the job have to be taken if the assistant will be working alone? This is the meat of the problem. So for the solution, let 1/6 be the rate of the plumber. So meaning, since the plumber can work alone in 6 hours, so what is the fraction of work done in 1 hour? That is the rate of work done. So the rate of the plumber is 1/6. And let x be the number of hours of the assistant working alone, because we don't know. So that will be our x. And let 1/x be the rate of the assistant. So meaning, whatever is the number of hours the assistant will work alone, then 1/x is actually the fraction of work done within 1 hour. And let also 1/4 be the rate of the plumber and the assistant. So we have here the plumber and the assistant working together. So I wasn't able to, something is lacking here, the rate of the plumber and the assistant working together. This means that within 1 hour, 1/4 of the work was done by the plumber and the assistant working together. Let's go back first to the problem. If the plumber and the assistant work together, they can finish the job in 4 hours. So, working together, so their rate is 1/4. Now, what is the LCD of 6x and 1/4? Well, the LCD is 12x. So we have here the working equation and rational in nature. We have 1/6 plus 1 over x equals 1/4. Then multiplying both sides, each term on the left hand side of the rational equation by 12x, which is the LCD. LCD is the least common denominator, meaning what is that value that can divide 6, that can divide x, that can divide 4. 6 and 4 are not relatively prime, meaning they have the greatest common factor. 6 and 4, they have the least common multiple, 12. Okay. Then on the right hand side, 1/4, we have to multiply it also to preserve the equality. We have to multiply by its LCD. Simplifying, we have 12x times 1/6, that is 2x. Then 12x times 1 over x, x will cancel out, that's 12, positive 12. And 1/4 of 12x is 3x. And solving for the value of x, we have x is equal to 12 hours. Hence, the assistant would take 12 hours working alone. Problem number 3. A water tank is emptied through 2 drains in 50 minutes. If only the larger drain is used, the tank will be empty in 85 minutes. How long would it take to empty if only the smaller drain is used? For number 3, we have solution. Let 1 over 50 be the rate of 2 drains to empty the water tank. So using 2 drains, the smaller and the larger drains, the water tank can be emptied in 50 minutes. So the amount of work done in 1 minute is just a fraction, and it's 1 out of 50 minutes. Or 1 out of 50, whatever is the whole 1 out of 50. Now, let also 1 over 85 be the rate of the larger drain. That means that, and it's stated in the problem, that the drain, or if we use the larger drain, the tank will be empty in 85 minutes. So meaning in 1 minute, 1 over 85 is the fraction of work done. The work there refers to emptying the water tank. And let x be the number of minutes of the smaller drain to empty the water tank. Of course, whatever is x minutes, then 1 over x be the rate of the smaller drain. And for this equation, we set up the required rational equation. We have 1 over 85. This is the larger drain, the rate of the larger drain working alone. And then the rate of the smaller drain working alone is, emptying the water tank alone is 1 over x. And if these two are joined together, they can finish, or if these 2 drains are opened together, they can empty the water tank in 50 minutes. So in just 1 minute, this is the fraction of work done. The LCD of 85, x, and 50 is 850x. Then we have to multiply both sides of this rational equation by the LCD. Doing that, We have 1 over 85 times 850x plus 1 over x times 850x is equal to 1 over 50 times 850x. This becomes 10x. This part will become 850 and this part will become 17x. Combining x, transposing this on this side, this becomes 17x minus 10x, that becomes 7x, and is equal to, retain it here on this side, that becomes 850. And dividing both sides by 7, we come up with 121.42 minutes. Or we can round it off to 121 minutes. Hence, it would take 121 minutes to empty the tank using the smaller drain if we round it off. But by rounding up, meaning there's an extra 0.42 minutes, so you can either take the 121 minutes or the 122 minutes as the final answer. Moving on to the last problem. Number 4. Working together, Tom and Jerry painted a fence in 8 hours. Last year, Tom painted the fence by himself. The year before, Jerry painted it by himself, but took 12 hours less than Tom took. How long did Tom and Jerry take when each was painting alone? Okay, so it was given here that the number of hours spent by Tom and Jerry working together is 8 hours. Okay, so let's try to take the solution. Let's try to see. So we have here, we let 1/8 be the rate of Tom and Jerry having painted the fence together. And we have here, let's consider first, let x be the number of hours Tom painted the fence alone. And the rate of Tom doing the job alone is 1 over x. And how did we get x minus 12? I will explain it later. X minus 12 be the number of hours Jerry painted. So there must be the number of hours Jerry painted the fence alone. There must be the word painted here. And of course, the rate of Jerry painting alone the fence is 1 over x minus 12. Oh, how did we get the x and the x minus 12? Here's the idea. It says here, Tom painted the fence by himself. And the year before, Jerry painted it by himself, but took 12 hours less than Tom. One technique that I want to teach you is between Jerry and Tom, in terms of their number of hours working alone, we have to consider who is less described, meaning what number of hours was less described. In this case, Tom's number of hours working alone was less described by the problem. Take a look. The year before, Jerry painted it by himself, but took 12 hours less than Tom. So whatever variable you place it in Tom's number of hours working alone or painting the fence alone, then less it by 12 hours because of this phrase. It took it took Jerry 12 hours less than Tom. So that is how we get x and x minus 12. If we let x be the number of hours painted or painting by Tom, then x minus 12 is the number of hours Jerry painted the fence alone. I hope you understand it. Now let's formulate our mathematical equation in terms of rational equation. We have the rate of Tom plus the rate of Jerry, that is their rate combined together, and they can work it together in 8 hours. So this is 1/8, the fraction of work done in 1 hour. So let me read 1 over x plus 1 over x minus 12 equals 1/8. Now what is the LCD of x, x minus 12, and 8? Well, we have 8x times the quantity x minus 12. This LCD will be multiplied to each term of the rational equation. And it's done here. Okay. Simplifying it. We have 1 over x times 8x. The x will cancel out. We are left with 8. But take note, we have also a factor of x minus 12. So times quantity x minus 12 plus 1 over x minus 12 here times the LCD. So the 8x will be left, cancelling out x minus 12 and x minus 12, equals the 1/8 times the 8 will be cancelled. That's 1 times x and times quantity x minus 12. So that becomes, now expanding x times x becomes x squared, and x times negative 12 minus 12x. Moving on, simplifying, we have expanding this 8x minus 96, 8 times negative 12, copy plus 8x equals, copy this whole thing here. Then, let's not disturb this term and transposing all the terms on this side. Okay, so we have x squared minus 12x. This becomes 16x when transposed minus 16x. That becomes here negative 28x. And the negative 96 here will become positive 96 when transposed here, leaving here the left-hand side 0, and swapping, we have this term. We ended up with a quadratic equation from a rational expression or equation. Then, this can be factored as x minus 4 and quantity x minus 24 equals 0. Solving for x, we have x equals 4 and x equals 24. Now, we're not yet done because we have to check the validity of the value of the two x's. Whether if we can take x equals 4 or x equals 24. Let's see. Checking it, we have, if we take x equals 4 hours, then x minus 12 will become negative 8. We know that if we take x, this is the number of hours Tom worked alone, and this one, x minus 12, is the number of hours Jerry painted the fins. Since this is not relevant to the problem because it will give us negative 8 hours, and there is no such negative hours. It has to be positive. It's a positive quantity. So meaning x minus 4 is or exists as a root, but actually it's an extraneous root or extraneous solution because it will make the problem not true or not relevant. Now let's take x equals 24. Well, this is not Tom's number of hours, and x minus 12, that's 24 minus 12 is 12, and it's correct. So we take x equals 24 hours for Tom painting alone the fence, and 12 hours for Jerry. Now we have to convince, or part of the procedure is to check with the original rational equation. So the original rational equation, this particular problem, is this one. Now we substitute the value of x equals 24. So we have 1 over 24 plus 1 over 24 minus 12. Is it equal to 1/8? Let's see. 1 over 24 and this one will reduce to 1 over 12. Then simplifying this one, we have 3 over 24 and 3 over 24 is equal to 1/8. Okay, and we're done with the solution for number 4 problem. For the numeracy skill, just visit the site. It's for your own enrichment. And so, our discussion on this module concludes. And this is Teacher Marichu saying always stay healthy and safe. God bless.